Okay, why is any of this important when it comes to graphing? Well, graphs are pretty important. It's very important to be able to connect the algebraic representation, y equals the sine of theta, and translate it to a coordinate plane, because you have an input and an output. So our input is theta and our output is y. And when I put 0 in, I'm just going to put my ordered pairs here. When I put 0 radians in, my ordered pair is 1, 0. And when I put pi over 6 radians in, my ordered pair is square root of 3 over 2, comma 1/2. And pi over 4 is 1 over the square root of 2. And pi over 3 would be 1/2 square root of 3 over 2. And then pi over 2 would be 0, 1. And then I would just start. So what I'm doing is, watch, I'm going this way. And then what's the next number? 2 pi over 3. Look, 2 pi over 3. And then 3 pi over 4. And then 5 pi over 6. And then pi. And then back to a pi over 6, and then back to a pi over 4, and back to a pi over 3, and back to a pi over 2. And then back to a pi over 3, back to a pi over 4, back to a pi over 6, back to a 0. So that's basically what's happening. So I'm just going to write these 1, 2, 3, 4, 5 values. And I'm going to show you what the graph looks like. Okay, so we'll make the sine, and you're going to want to graph these like parent functions. You know how you can graph parent functions very quickly? You're going to want to graph these quickly. So listen to my language. First, I'm going to show you this one time where this graph comes from. It comes from the values. You put a 0 in. Look, this is your input. That's your input for your angle. What do you get out? You're going to get the y value out. So when you put a 0 in, you're going to get a 0 out. That's the origin. Okay, next value we're going to put in a pi over 6. Pi over 6 is, where is pi over 6? Pi over 6 is, look, 1, 2, 3. 1, 2, 3. 1, 2, 3. Doesn't that look like your unit circle just stretched out? It does, because it is. So pi over 6, you put a pi over 6 in, and what do you get out? You get out 1/2. So I put a pi over 6 in, and I'm going to get out a 1/2. Then I put pi over 4 in, and I get 1 over the square root of 2. And if you put 1 over the square root of 2 in, I believe you're going to get something like a 0.7-ish. Okay? Then when we put in pi over 3, let's get all of these highlighted. Then when we put in a pi over 3, we're going to get square root of 3 over 2. And the square root of 3 over 2, maybe that's 0.7-ish. We should probably check. Okay, yeah, the dogs are going to go nuts in a minute because it's beautiful weather outside and we can hear dogs barking because the window's open. Divided by 2. Yeah, 0.86, so 0.87-ish. So 0.87-ish. I'm right about the 0.7-ish. I know I am. So you can trust me. And then you put pi over 2 in. This is where it's starting to get cool. Like, not cool as in cool weather. This is where it's starting to get pretty sick right here, this graph. Put a pi over 2 in, you get a 1 out. So look, we've got this going on. And that's nice. Nice trying. Okay, then what's going to happen when you put 2 pi over 3 in? Well, you're going to get that same 0.86 again, right? It's right here. And when you put a pi over 4 in, you're going to get that 0.7-ish again. And actually right there. And then when you put the pi over 6 in, you're going to get 1/2 again. And then what happens when you put pi in? When you put pi in, you get 0. See, isn't that neat? And then that's quadrant 1. This is quadrant 1. This is quadrant 2. What's going to happen in quadrant 3? Well, all those values are going to repeat again, but this time they're going to be in the negatives because now we're going to have values. Let me show you. We're going to have values that are below. See all these y values? They're all below the x-axis. And when your y values are below the x-axis, it's called negative. So you learn something new every day. Okay, so this one right here is going to be 1/2. And then the next one's going to be 0.7-ish. 0.7-ish. And then the next one is 0.86-ish. And then the next one is -1. And do you see how they're going to repeat? They're just going to repeat. It's really a true story. There you go. So this is what I'm going to tell you. I'm going to tell you. So this is one period. This is one full cycle. One full cycle. Okay, one full cycle, which is the period of the function. Because it's just going to repeat itself over and over and over again because you're just going around in a circle. So you're just going to get, after you go to 2 pi, look, after you go all the way around and get these y values. Well, I didn't quite get the y values. Y values, y values, y values, y values. Once you get these y values, right, there's a y value, y value. It's there you go. Now we're repeating. Do you see that's we're repeating? We're repeating. And then what's going to happen a third time? Then it repeats. And what could have happened? I could have gone the opposite way. I could have gone into the negative angles. And do you see that I'm going to get all those y values? And then I could keep going that way forever. I'm going to just tell you with my language what happens. Okay, listen very closely. Sine starts at what we call the midline. So this right here is called the midline. That's the middle. So the midline is at y equals 0. We have a maximum and a minimum. So sine starts at the midline, ends at the midline. Halfway through, it's at the midline. Listen to me again. Starts at the midline, ends at the midline. Halfway through, it's at the midline. Halfway through the first 2 points, halfway through these first 2 points, we're at a maximum. Halfway through the next 2, we're at a minimum. Connect the dots, and we've got our sine curve. Okay, let's try that again with red pen. Starts at the midline. 2 pi later, it's going to end at the midline. Now I'm going to the left. Halfway between, it's at the midline. The pattern will continue. This time, it's going to go down to a minimum, and then up to a maximum, and end at 2 pi. How many of these do I have? Oh, I've got plenty. I'm very prepared. Okay, here's y equals the sine of theta. I'm going to do this one more time. Sine starts at the midline. The midline is the x-axis. 2 pi later, it ends at the midline. Halfway between, it's at the midline. Between the first 2 points, we're at a maximum. So between 0 and pi, we have an input of pi over 2. That's going to be at a maximum. Halfway between pi and 2 pi, which is an input of 3 pi over 2, we're going to be at a minimum. Our minimum is -1. So we've talked about this before. Sine and cosine will never have ratios greater than 1 or less than -1. Okay, let's continue this pattern to the left. So sine starts at the midline, 2 pi later, ends at the midline. Halfway between, it's at the midline. Halfway between 0 and -pi, at -pi over 2, we'd get a minimum of -1. And halfway between -pi and -2 pi, which is at -3 pi over 2, we would have a maximum of +1. and our graph would continue like that. And if we could continue on, it would go down like that. If we could continue on the right, it would go up and keep going. But that's all it does. So that's all we have room for. So there are 2 full periods, 2 full periods. So that's how our sine graph works. That's how the sine graph works. Okay, let's practice with cosine. Okay, y equals the cosine of theta. I could go through all those ordered pairs again, but I'm just going to explain to you. You can go through the ordered pairs. You know how I did that. If not, you can rewatch the video. We still have a midline here. That's a halfway mark. Right? It's halfway between your max and your min. Our max and our min is still going to be 1 and -1. For cosine, the cosine curve starts at its maximum of 1. So at 0, we have an output that is 1. 2 pi later, it's going to end at that same exact spot. So 2 pi later, it's at the maximum. So cosine starts at the maximum, ends at the maximum. Halfway between, when our input is pi, we're at a minimum, and the minimum is -1. Halfway between maximums and minimums, you're at the midline. That's why it's called the midline, because you're in the middle. Halfway between the minimum and the maximum, you're in the middle. So here's 1 full period. So this right here is 1 full cycle which equals the period for cosine of theta. So that's 2 pi. But since I have room to the left, I can draw another full cycle. So starts at the max, -2 pi, that would be 2 pi later to the left, ends at the max. Halfway between, we're at the minimum. Halfway between the maximum and minimums, we're at the midline. Halfway between the minimum and maximum, we're at the midline. And now we have enough that we can draw our cosine curve. So that's our cosine of theta. Okay, before I show you the tangent of theta, I want to work a little bit more with sine of theta. So what happens if I have a negative on the outside of the function? Okay, if I have a negative on the outside of the function, it's going to reflect it. So this is going to reflect over the x-axis, or in this case, the theta axis. So rather than starting at the midline, ending at the midline, halfway between midline, and then halfway between those two having a maximum, now it's going to flip and it's going to become a minimum. And halfway between the next two is going to end up being the maximum. Okay, so I'm going to draw in gray what the graph would have looked like. So that's what the graph would have looked like, but this is what the graph really looks like. And I'm going to continue that red graph to the left. Sine starts at the midline, 2 pi later, ends at the midline. Halfway between, it's at the midline. Halfway between 0 and -pi, this would continue up to the maximum of 1, and then it would go down to the minimum and over to -2 pi. What happens if we have y equals the sine of negative theta? The sine of negative theta. Well, that means that we reflect over the y-axis. So let me graph the sine curve in a gray dashed line. So that's what it normally looks like. Reflecting it over the y-axis. Let me finish it over here so you could kind of see the whole thing. If I reflect over the y-axis, this point is on the y-axis, it stays, but pi over 2 +1 becomes -pi over 2 +1. So this point reflects over the y-axis. And we have a reflection, and we have a reflection, and then we have a reflection, and we have a reflection. So I think I've reflected all of the x-intercepts. Oops, I forgot that reflection. So there's our sine of negative theta. Wow, sine of negative theta looks just like negative sine of theta. It's pretty cool. Okay. Let's see if cosine of negative theta and cosine of positive theta are just as cool. I'm going to duplicate this page because we're gonna need some more graphs. And the good thing for you is that it gives you the opportunity to draw the graphs and not just, you know, always worry about being given a graph. You can create your own graph. But I want the next two to be on the same grid. So I think what I'm going to do, because I'm having so much fun with this, is I've already shown you sine, I've shown you the parent function for cosine, and I showed you a little bit about transformations for sine. This is where we're going to take a break. We're going to go to the next video, and I'll show you some transformations, reflections for cosine, and then I'm going to close it up with our